Welcome to lesson 1.2. In this lesson, you are going to learn how to solve equations that require multiple steps. So in the last section, all equations required one step. Now they'll just require more than one step. So for our first example here, it is a word problem, and it says the height in feet of a truffula tree after x years is given by this expression, x divided by 2 plus 14. So that is the height of the tree represented with an expression. And it says after how many years is the tree 17 feet tall? So we want to know, when is the height of the tree equal to 17 feet? When is x divided by 2 plus 14 equal to 17 feet? And here it defines the variable for us, but let's formally define it, that x is the number of years. Number of years. This actually is a math symbol right here. The colon in math means defined by. Defined by. So x is defined by the number of years. So we need to solve this equation here. So anytime you've got a variable in one of your terms, terms are separated by addition or subtraction. So anytime you have a variable in one term, we need to isolate that term. So we need to get rid of the adding 14. So what undoes addition? The inverse operation of addition is subtraction. So we need to subtract 14 from both sides of our equation. That will cancel out the adding 14. And now x divided by 2 is by itself. And that was our goal, our first goal in solving this equation. 17 minus 14 is 3. And now that the variable is in a single term here, we need to undo dividing by 2. So what is the inverse operation of division? And that is multiplication. Multiplication undoes division. So we multiply both sides of this equation by 2. That will eliminate the dividing by 2. Now x is all by itself. That means x is solved for. We have x equals 3 times 2 is 6. And x is, again, the number of years, so I'm going to put 6 years. And there is the answer. But this is a word problem, so I should write my answer in a sentence. So again, it says, after how many years is the tree 17 feet tall? So after 6 years, the tree will be 17 feet tall. And there is my answer in sentence form. So if you have a word problem, please always do 4 things. Define your variables, write the equation, solve the equation, and write your answer in a sentence. Alright, looking at example 2, to solve this one, we actually have a couple of like terms. These like terms are like terms because they both contain x's. It tells you how many x's you have for each of these terms. So in this one it says we must explain our steps. So to explain my steps, I'm going to, on this first step, combine like terms. 9x minus 4x is 5x. And I've actually got these typed out ahead of time, so I'm combining like terms. On my next step, and perhaps I should put that here, combine like terms, that's how I got from the first step to the second step. On my next step, I'm going to undo addition to get the term with the variable in it by itself. So I need to subtract 7 from both sides. And negative 12 minus 7 is negative 19, which equals 5x. And what I did in that step, because I subtracted the same quantity from both sides of my equation, I used the subtraction property of equality. Alright, on the next step here, I've got 5 times x. I have to undo multiplication, so I need to divide both sides by 5. And 5 over 5 is 1, so that cancels that out. And that is called the division property of equality. So on that step, it's the division property of equality. So on this one, 5 goes into 19 3 whole times without going over. So it's 3 and 3 times 5 is 15, so I'd have 15 fifths. I need 4 more fifths to get to 19 fifths, so I have 3 and 4 fifths. And because this was a negative, this is also a negative. And it says equals x, so I can put equals x. And the conventional way of doing things is putting the variable on the left. So x equals negative 3 and 4 fifths is my answer. And this one is not a word problem, so that is a reasonable answer. So I'll just circle that, and that's it. Alright, just a few more examples to go. So on this one, it says, again, solve for x and explain your steps. So on this one, I've got a quantity outside of parentheses, and some of you might think I need to distribute that into that parentheses right away. But remember, our goal here is to solve for x. It wouldn't be wrong to distribute the 2, but then you'd have to divide out the 2 later on, and then you'd make this into a larger number. So that isn't our only possibility here. Another possibility is to think of, how do I undo addition? Let's get that 7 to the other side, and that's what I'm going to do first on this one. So I need to use the inverse operation of addition, which is subtraction. So I'm going to subtract 7 from both sides of my equation, and I will get 2 times the quantity, x minus 2, equals negative 8 minus 7 more is negative 15. So to justify that step, that is the subtraction property of equality. Now, again, you could distribute that 2, but then I'd eventually have to divide it off anyway. So what I'm going to do at this step is divide both sides by 2. And that will cancel out multiplying. So this is ultimately just 2 times this quantity. So I can divide off that 2 and get rid of it, because 2 divided by 2 is 1. All right, so now I've got x minus 2 equals negative 15 halves is negative 7 and a half. So on that step, what I am using is the division property of equality, because I'm dividing both sides of my equation by the same quantity. And then finally, to undo subtraction, I need to use the inverse operation of subtraction, which is addition. So I'm going to add 2 to both sides of my equation, and that will turn this into x being by itself. So I have x equals negative 7.5. If I add 2, I get negative 5.5. And what I did there, because I added the same quantity to both sides, is the addition property of equality. So that is my answer, x equals negative 5.5. All right, 2 more examples to go here. So on this one, very similar, solve for m. On this one, I've got 2 quantities that have m in it, and it wouldn't do any good to subtract off one of these quantities, because then I'd have m on both sides of the equation, and to solve means get m by itself. You want to have m on one side of the equation. So on this one, it doesn't do any good to not distribute. On this one, I have to distribute both the 3 and that positive 7. So multiplying, distributing in the 3, I get 3 times 1, which is 3, minus 3 times m is 3m, plus 7 times 2 is 14, and a positive 7 times a positive m is a positive 7m, so plus 7m, and it still equals 4. So what I'm doing on this one is just using the distributive property. All right, so next up, do I have any like terms here that I could combine? And yes, I definitely do. I've got a negative 3m and a positive 7m. Those are like terms because they both tell you how many m's you have. And then I also have a positive 3 and a positive 14, so I can combine those together as well. So first up, I'll do 3 plus 14 is 17, and negative 3m plus 7m, or 7m minus 3m, is positive 4m, so plus 4m. It still equals 4. So on that one, I am combining my like terms. All right, so next up, I have, excuse me, I have to get the term with the variable in it by itself. So how do I get that positive 17 tied on with addition to the other side? Well, I need to subtract 17 from both sides. 17 minus 17 is 0, and that's why I wanted to subtract 17 from both sides. And now I get, by the way, if you can hear my son sleeping, he's sleeping on the bed next to me, so sorry if you hear some snoring. Anyway, I have 4m by itself equals 4 minus 17 is a negative 13. So to describe that step, I am using the subtraction property of equality. And finally, to undo that multiplication, 4 times m equals negative 13. To undo multiplication, the inverse operation of multiplication is division, so I need to divide both sides by 4. And then I get m by itself. I solve for m. M equals negative 13 fourths. So it's a negative, so my answer is a negative. How many times does 4 go into 13 without going over? And that's 3 times, because 4 times 3 is 12. So I have negative 3. Well, again, 4 times 3 is 12, so that's 12 fourths. Negative 3 is negative 12 fourths. I need negative 13 fourths, so I need one more fourth. So negative 3 and 1/4 is my answer. And just to describe that last step here, that was the division property of equality. All right, last example coming up. So on this example, another word problem, it says our drama club charged $4 per person for admission to a play. The club borrowed $400. That means they gave away they took in $400, but that's not their own money, so they'll have to pay that back. So I'm thinking that's a negative $400. After paying back the loan, the club had a profit of $100. So that's a positive $100. So let's break this down a little bit. I see a keyword right here. It says $4 per person. Typically, when you see that word per, that means that amount, $4, will keep happening over and over and over again. They're charging this amount. They're getting $4 per person. So that's a positive $4 per person. So with that word per, that tells me I need 4 times x, 4x, because every time another person pays, I get another $4. So if 5 people pay, well, 5 times 4, that's $20. If 7 people come in and 7 people pay, 7 times 4 is $28. So every time you get another person, you increase by $4, so 4x. That's how many 4s you have. You have x 4s for x number of people. All right, so again, this 400 says we are borrowing 400, so we're going to lose $400. That's a negative 400. The profit is a positive $100. So let's try to write an equation for this this word problem here. So it says that we're charging $4 per person, so we're going to make $4 for every person. I used a variable, so I want to define it. X is defined as the number of people, or number of people attending the play. I'm just going to put number of people. All right, so 4 times x, that's the amount I make per person, but we lost $400 here, so I have to put minus $400. So the number of dollars I'm making per person minus the 400 that I had to borrow originally, and it says we're going to have a profit of $100. So the total amount of money I make, this represents the total amount of money, the amount of money I make per person minus that initial $400 loan. The total amount of money that I'm going to make, it says, is a profit of $100. So it is $100. So there's the setup of my equation. So now I need to solve this equation. So how do I get that term with the variable in it by itself? So how do I get the 4x by itself? I need to add 400 to both sides. So undo subtraction. I'm using the addition property of equality. And it does say that we have to, I'm sorry, it doesn't say we have to explain our steps. So I'm sorry, I had to record this already. My microphone broke as soon as I started recording it, so I already have my answer sitting over here. So I'm going to keep that hidden. All right, so I'm adding 400 to both sides. So I get 4x equals 100 plus 400 is 500. Divide both sides by 4, the inverse operation of multiplication. That will cancel out my 4's. And now I have x by itself. 500 divided by 4 is on 125. And because this is a word problem, I have to do 4 things. So I define my variables, I did that. Write an equation, did that. Solve the equation, that's done. But 125 what? Well, x is the number of people, so 125 people. So that's my answer, but because it's a word problem, I have one last thing to do. There's those 4 things: define the variables, write the equation, solve the equation, and then write a sentence. And that's what I had hidden over here. So 125 people attend the play. And that is my answer in sentence form for this word problem. So there you go. So your assignment is a worksheet called 2-step equations. You'll find that on Schoology. And for this one, you only have to do the odds. Thank you.